All right. Welcome back from the break, the lunch. I don't know. I forgot. I'm in different jet lags already. Hi, I'm Bruno Borges from Microsoft.
And I'm Jeff Hollan, also from Microsoft.
And we are here to talk about serverless. And I know many of you have heard about serverless before. And for those that have not, welcome. For those that have, we can actually dive into Azure Functions, which is Microsoft's implementation of serverless computing, which is also open source. We're going to provide some details. But we're going to walk you through how to create a function, how does it work, what you can do with it, some use cases, and so on.
Yep, this is a fun session, whether you're new to serverless or you've used it before, giving you a more behind-the-scenes look than you'll find in pretty much any other way. And part of that's the benefit, as Bruno mentioned, that this is open source. So hopefully this is valuable. We will have some question and answers at the end as well, but we've got some cool new content here and some exciting demos as well.
Exciting demos that should work.
Yes.
So I'm part of the developer relations team for Azure, and I lead the Java team. I came from Oracle, and it's a pleasure to be at Microsoft working with awesome people like Jeff, who has been working on implementing Azure Functions and the Java support. So it's great.
Yep, that's right. And I've been at Microsoft now for about 5 years, been focused on serverless for about the last 3 or 4 exclusively, and am now the one in charge of the Azure Functions runtime.
All right. So the program?
Yep, we'll start. We'll give a basic overview. By raise of hands, how many of you are already familiar with what Azure Functions is? Is anyone here? So just a few. Yep, a few people are, some kind of. So we'll give a brief overview of Azure Functions, and we're going to dive pretty quickly into some behind the scenes to give you a sense of what the components of Azure Functions are, from the open source runtime, the developer experience, scaling. We're going to talk about some patterns and best practices, and then have some Q&A.
Sounds good.
So to start with, this is a brief introduction of Azure Functions. At its core, what are Azure Functions? The kind of simple 3-word, I guess 4 words with a hyphen, definition is event-driven serverless compute. So if we break that apart into its individual pieces, when we talk kind of working backwards, compute, this is your code, whether it's your Java code, your JavaScript code, your C# code, your Python code. You take your code, and we'll run it for you in a serverless way. Serverless really at its core just means that the infrastructure is managed for you. You don't have to think about servers. You get to think about servers less. Okay, so it's really optimized for their scenarios where I have this bit of code running, I have this script running. To get it to the cloud, I don't want to have to now manage 20 things. I just want it to work. I just want it to run. And that's what serverless allows you to do. We will spin up the resources needed for your app on demand. We will run it at whatever scale you require without you having to configure anything. In order for that to work, though, it does need to be event-driven. There needs to be some event that lets us know to run your bit of code. Now, those events are very flexible. Those events might be an HTTP request. It might be a message gets dropped in a queue, a Kafka message is received. It could be we added a new customer or we hired a new employee. These are all different types of events that let us know, hey, run my little bit of code. So we'll show you some examples in a little bit, but that's really what Azure Functions is and the benefits that it provides.
And just to add to what serverless is at the end of the day for us developers, it's just that we don't care anymore. We don't care about writing Docker files. We don't care about kubectl commands. We don't care about setting up memory and CPUs and all of that. We just give it to you, and you deploy the code.
Yep, exactly right. So the core components of a function, there's 4 that will be key to understand as we go throughout this. The first, when you're building a function, you create a function app. This is kind of the boundary of a single application. You can have as many apps as you want. This will be your unit of deployment and your unit of scale. It can be comprised of multiple functions. So I could have a single app that has add customer and delete customer as 2 separate functions that I could deploy as a single app. The thing to remember with this is if I want to make a change to a function, I make the change at the app level. I can't change just one individual function. I deploy it as an entire app, and that app will scale as a single unit, and we'll see that in action as we move on today. Those function apps are made of individual functions. I kind of gave you an example, create customer, delete customer. Those might be functions. It can be written in a variety of different languages, and we even allow you to extend the runtime with your own language workers. The trigger, this is the thing that lets us know to run your code and the data that we will push into your execution. I kind of talked about some of those before. HTTP is really common. Run this code when you get a web request or an API request. Queues, event streams, database changes. These are all different types of triggers. A unique concept to Azure Serverless story is this idea of bindings. We actually find that developers love bindings, and Bruno's going to show us more about them in a bit. But the only thing I'll explain for now is that this is data that can be pulled in or pushed out of each one of your executions. You can almost think of it in that if I'm creating a customer, there may be some reference data that I want to pull in from a database as well as my trigger data. Bindings allow you to bind to some reference data or to output some reference data or to output some artifacts as a result of an execution without you having to write code. You can simply define those bindings to other data sources, and the function runtime will take care of that for you. We'll go into that a little bit more in a second, but it's important that you understand where that fits in to the story. So kind of here's a visual representation of what a function looks like. You have your trigger, which fires. It might pull in some reference data from one of our bindings. In this case, I'm using a NoSQL database like Cosmos DB. And once my execution is completed, I might push data out to storage. Now, one cool thing about Azure Functions is that we will scale and run this bit of code at whatever demand that you might need. And you only pay when your code is actually running. So if you deploy a new function API and never call it, your bill will be $0. If you call that thing 1,000,000 times, your bill's still going to be $0 because we give you 1,000,000 free executions a month. But if you call it 1,000,001, you only pay for that tiny bit of compute when it was running for that time. So very efficient model for building applications that can scale to whatever needs that your application has.
In Jeff, I presented something at Jug recently, and somebody said, but I'm small, and 1 million is great, it's free, but what if I go over 1 million? How much would that cost? And I say, well, you're going to have to pay something. And so, what if I go to 2 million or 10 million or 100 million? Then I said, well, then you have a startup, so you should be making money out of it. Like, it's time to make money.
Exactly. Pay as you grow.
Yeah, exactly.
Pay as you grow.
It's a good way to get started. And speaking of getting started, this is the most simple code that you can see with all the key elements of a function written in Java. So you have the annotation of @function name that goes into a method. The method is the function. You can have one class with multiple methods and each method annotated with function name, which means you're going to have a function app with 3 functions. You can even have multiple classes in the same project with function name annotation in different methods in different classes, which means you're going to have multiple functions in one function app deployable unit. The other thing that you need is a trigger attribute. And the trigger attribute has to be only one. You cannot have more than one trigger on any given function. And for different types of triggers, you're going to have different parameters. HTTP trigger requires what kind of HTTP method is supported, what kind of authentication is required, and so on. And then you have the different types of bindings. So the bindings, as Jeff said, is the binding of input and output data. And you can have multiple of those, both for input and output, which is a nice way of connecting to the services that the platform has already implemented those binding capabilities. Last thing is the execution context. The execution context object provides you an API to access certain things that you don't have access to normally. For example, how do you create a file? Where do you get the logs? How do you send a log to somewhere? Because all of that is not exposed to you. So that's why you need the execution context to figure out certain things. And the most important object that you can get is the logger. So you can send data to the logging feature of Azure Functions. So when you think about creating a function in Java, the best experience that you can get is with Maven. There's a Maven archetype, and there's a Maven plugin. You do have to install the Azure Functions core tools, which is the engine of Azure Functions, so you can run locally. With that, you don't even have to have an Azure account, right? You can just develop locally, and then send the code to somebody who actually has the Azure account for you. But once you install that, the Maven plugin, especially the Maven plugin, will use the Azure Core Functions tool to generate all the files that are required to run your Java function on an Azure Functions runtime. So let's take a look at this demonstration live. So I'm going to go here, and this is I created this code for Maven archetype, which is all the parameters, so I don't have to type anything. I'll just press enter. It will generate the project, and once the project is generated, it gives you an HTTP function with HTTP trigger, and you can just go to the project, say Maven package, Maven Azure Functions run, and you have that locally on your computer. Once you have an Azure account, which you can get anytime, you authenticate using the Azure CLI, and you don't need to put credentials on your project. The Maven plugin actually uses the Azure CLI to authenticate against your Azure subscription account. And then with that, it will deploy the function in the cloud for you. The other thing that you can also do is on VS Code, you can debug your project. And because this is a Maven project, it's a normal Java code. It's a normal Java project. The only difference is that there will be a JSON file that is generated with the annotations that are in your code. That file is what tells Azure Functions how to bind the data and how to trigger the events. The other thing that I can add while Maven is figuring out his archetype thing is the Maven Dependencies. It's a Maven project, means you can add any Maven dependency, including a JDBC driver if you want to open a JDBC connection to the database. Of course, there are better ways to do that, but it's a Maven project as usual. So let's go into the project. So this project is a Maven has a POM. Those JSON files are generated by default, the function Java, and then it has some tests. What it can do here is just show you the function. So this function, class function, package, whatever, imports, and then it has the function name with an HTTP trigger. This is the name of the API. So this will be the /API/this value. What kind of methods do I want to support? What kind of authentication do I want? So it is a function authentication, which means I have to provide an API key at the function level to be able to call this function. So by default, your function, even if you deploy this, it's secured by default. You have to actually do some work to make it anonymous and work for anybody. So the other thing is, and this gives you the object HTTP request message, which is your request, and then you can get parameters from the query, or you can get the body. Because this code supports get and post, which means I will try to get the, I'll get the name parameter, but I will get the body. If the body is empty, then I will use the name that was provided as a get parameter. So let's just show this on Visual Studio Code so we can run this thing. So one thing with VS Code that we can do is activate this project for VS Code development. And I'll just select this project just generated. Now this gives me some nice capabilities on VS Code, such as running and debugging locally. So I can come here and I can just say run. This will start Azure Functions. It will deploy the Java function on top of it, and then it will attach VS Code to the JVM, so I can see what's going on with my code. So I'm going to put a breakpoint over here, and here's the URL. I'll just copy that, or actually, let's do this. I'll create a nice file called calls.http. And Jeff loved this thing.
I'd never seen this before. This HTTP add-in is pretty slick.
And then I'm going to say name equals Bruno. And I'm going to send a request. And then here's the breakpoint. And I can just walk through. And then the name is Bruno. And then I'm going to just resume. And that generates an HTTP response. Hello, Bruno, with HTTP code 200, which is specified here. So HTTP status OK, body, hello, Bruno. That is the most simple way to get a function up and running locally. Now, if you do want to just run locally without debugging or anything and just using Maven, and you can do this from any IDE, you can just do Maven Azure Functions run, which is the Maven plugin will do the job for you.
And what's cool here is throughout this entire project, he hasn't even had to talk to Azure. This is 100% running locally. We'll talk about this later. This is the same runtime that would run if it was running in the cloud,
Yep.
but you're able to develop it, debug it, run it all locally on your machine.
So once you have your function ready, you can just go and do Maven Azure Functions deploy. Now, this is a project that just got generated, so it actually doesn't have the parameters required to deploy it. So let's just take a look at how we would do it. You can go to the POM file, and on the Maven plugin for Azure Functions, which is this one, you can say, what is the resource group? What is the application name, the region, the data center, and then some app settings that you can provide. This one is actually generated by default for you, and this provides, okay, what is the minimum version that I want from extensions, and what is the website run from package, I'll just flag, and all of these got generated for you. You can actually check the documentation for find more details. One interesting thing that was added to the latest version is that you can now say property name Java OPTS, and you can provide a value that you can say x minus s, 32 megabytes, and mx, 32 meg. So you can actually provide an options for the JVM. So Azure Function will create the JVM using those parameters. So you can optimize the JVM based on the kind of function that you implemented. And Azure Function will just use those parameters. We have some defaults, but we can replace those with these values. So once you have this information, resource group, the app name, the region, all of that, it will just deploy. Now, it does take a couple minutes, and we don't want to just watch the terminal and waiting for an upload and creation and everything. There is actually a function that I already deployed, which is this one, and it's very similar, but it is already up and running, and you can see here the Hello Func Devoxx on Azure websites. Now, I just clicked on the send request, and it will take a little bit of time because there is something that Jeff will cover in a moment, which is called code startup. And code startup is a problem that any serverless platform has to face it. Once the code startup happens, the next execution is quicker, as you can see. But the very first execution might take some time. And to deploy this thing, all I did was Maven Azure Functions, deploy. Now, it already deployed once, so now it's an update. The update, one thing that I just want to show you is that it fails. Oh, yeah, of course, cd hello func. I was not in the folder. Maven Azure Functions deploy. What I want to show you is that the plugin will use the Azure CLI. The POM file does not have username, does not have password, does not have a subscription key, API key, or anything like that. The plugin will use the Azure CLI to get the authentication token and then communicate with Azure. And we can see the Azure CLI, AZ account show, that I'm already authenticated. This is what is interesting. So you can actually share your project with other developers. You don't have to provide those information. If you do have one subscription that has multiple developers working on, then what you can do is have a principal, a credential, and then you can share that information with multiple developers. So that was the very basic hello world of Azure Functions.
Perfect.
Which is, yeah, this.
So a few sample scenarios. These are the most common use cases that we see people using functions for, and I'll give a few examples as well. Web application backends or mobile app backends. This is very similar to like what Bruno showed, where you have something that's HTTP triggered, maybe being called on the backside of an API call. One of the big use cases for this is CarMax. I don't know if you're as familiar with them, but they're a large car retailer, and they have a large car online presence. They're actually leveraging functions to power some of their backend APIs, so that as their demand grows, as the API usage grows, it just expands serverlessly behind the scenes for them. IoT backends is a similar story. Kind of like to what Bruno was saying for startups, IoT and serverless are a really nice fit, because often IoT projects start with just a couple dozen devices, and you plan to grow those devices over time, but when you first ship the solution, you might just have a few. And functions is great for that because you might only have a few calls at the beginning, and then as you add more and more, if not hundreds of thousands of devices, your application just automatically scales. You don't have to go re-architect the application as you grow. We've got a few customers who are using it for IoT connected backends, specifically for things like ABB is one of the customers here who's doing it to monitor manufacturing lines. Zeiss is another one, a customer who's doing this for IoT backends. Conversational bots, real-time file processing or stream processing. It's really common, and Bruno's even going to show an example. Hey, I uploaded a file to the cloud. I need you to transform it. Fujifilm has a website, and obviously they deal a lot with photos. As photos get uploaded into storage accounts, they have serverless functions that can automatically go and manipulate those images automatically in the backend for them. Automation of scheduled tasks. Anytime there's a job where it's like, hey, Bruno, it's Friday at 3 o'clock. Can you run that cool script you have that cleans the database or whatever else it might be? Instead of us always having to call Bruno, Bruno can just publish that job to the cloud as a function and have that just be run on demand. And extending SaaS applications. I'll show this in a second. I'll actually extend Twitter and run some processing on top of Twitter as we go. So those are some of the key scenarios to kind of get your brain thinking of use cases that you might have, which brings us some of these kind of connecting to other services to a little bit deeper look at bindings.
Yeah, as we said, the bindings are the components that glue with services, and those services don't have to be Azure services. They can be actually external services. There's a component binding that allows you to connect to other databases, including Oracle database or DB2, God forbid, but it's possible. And here's some of the table shows just some of them. And actually, behind those components, those bindings, you can actually see that they have subcomponents and subfeatures. But the most important thing about the bindings is that they are just a declarative way of setting up inbound and outbound data into your function. Actually, what you can do with bindings, you can do with SDKs and REST APIs and integrating with the services manually and so on. But if you do use the bindings, you take advantage of the platform. And that provides you even less code to write, even less code to maintain, and those things will evolve naturally by the vendor. The vendor will implement that. In that case, Microsoft will implement and evolve those bindings to the latest versions of the services. So the storage binding component, let's say there's a new version, a new REST API of the storage service. The binding gets promoted, and you just take advantage of that. So those are the nice things about the bindings. Although, if you do want, of course, to take advantage of advanced features, then you can, of course, just extend the dependency of your Java SDK for this service or that service and use that programmatically from inside the function. The extensions which provide the capabilities of the bindings are evolved independently from the runtime, which means the Azure Functions runtime on version 2.2 can remain on version 2.2, but the Cosmos DB extension can continually evolve for new features of Cosmos, and you just get advantage of that. And as we said, functions can have multiple bindings. If you do want to check out the documentation, that's the URL. Or just search for Azure Functions bindings on Google or Bing, and you should find
it.
On
Chrome or Edge or Firefox.
Or Firefox, exactly. The one thing that I do want to show you quickly is what does it look like to configure these bindings and these extensions, and how can you manually evolve them if you want to, or even configure. So this is the XML file that is generated for the Azure Function project. And this is where you set the extensions and which extensions you're going to use manually if you want to. But that, technically, the plugin actually takes care of this for you. If the plugin detects there's a Cosmos DB annotation in your code, it will input the Cosmos DB extension here. But you can come here and manually override that with something else, or a new version, or a downgraded version, and have more control over the extensions that are enabled for you in the runtime. So let's take a look at code that is a little bit more sophisticated, using the bindings and triggers and SDKs. We have a project that is hello Devoxx.
Is it this? Is it that analyze one?
Yeah. It's the no. It's the one that is broken. This one.
Ah.
Not broken. I'm sorry. Split it. The screen split it. It's not broken. Split it. So this service, this function. Let's take a look at the code. And actually, let me just confirm that I don't have any other function running. I don't think I do.
Good call.
Yeah, it will probably tell me if there is. So this code, this Azure function, will be triggered not by HTTP, but by files being uploaded to a storage container. And here I have Storage Explorer. I'm connected to a storage account, and I can upload or manage files manually here. But as we all know, we want to automate things. So I'm going to manually upload a file, and then that file will be triggered, will trigger an event to my function, which is a blob trigger that is connected to the path images using a connection called Azure Web Jobs Storage. So the path images matches this thing over here, images. And the data type is binary, of course, is image. I'm going to upload images. And this information here, the Azure Web Storage, this is defined on the local settings. So this local settings JSON file is where you put all these environment variables, and these can be read by your function. You can just do system.getEnv, but they are also used by the extensions and the binding configuration and the trigger configuration to connect to your event source or your data bindings. So here I have the Azure Web Storage, Web Jobs Storage, and here's the default endpoint, here's the key, the name, and everything. I will not show you the entire key, or else people will freak out. So here's the code now, the Java code, that gets that image, and then, I forgot, the Cosmos DB output. Once I have that image, the function will process the image, and then we'll extract metadata, and then we're going to store that data on the NoSQL database. But instead of opening a connection to the NoSQL database and pushing data to it, we're just going to get that connection automatically through the binding. So we have an output document, a database name will be images, and the connection name is analysis, and the connection string is Cosmos DB connection, which is set over here, Cosmos DB connection. And it's the same thing. There's a URL and an account key, and very nice and beautifully protected, so nobody takes it. Once I have all that, I can start using my actual business code. So the business code is split in two classes, the Vision Inspector, which will use cognitive services, which is the AI service that I put an image in, and it provides me all the information that it can possibly get. And then I'm going to convert that into a JSON that will be stored in the output document, which is Cosmos DB. And this is like I just did this code, which is kind of using lambdas and observable objects. But here's the inspect, which actually triggers the entire flow. So let's take a look at the inspect. Oh, and by the way, the key to connect to the cognitive services is also available as an environment variable from the JSON file, which is over here and over here. All right, so once all of that is done, I go to my Vision Inspector. And here's the interesting code, because this is not using binding, it's not even a trigger, it's actually the Cognitive Service SDK, which means it's a Maven dependency on my code. And here it is. It's a Maven dependency as you would do on any Java project. You can actually add any dependency you want. You can add any kind of Java dependency that you might need to implement your code. So once I have that, and here's the method inspect. Well, on the constructor, I create a computer vision manager, I create an authentication, I get the endpoint, and then I get a computer vision client object. And the inspect object is the one that will analyze the image in a stream, which is this byte array with these features. And the features I want are all the types of features available that are visual featured, like color, type of object, position, etc. And then I'm going to execute that. The interesting thing here is that I could actually do execute asynchronous and put that in background. And my function would just be ready for more executions later. So in this case, I am blocking. And once that is provided, once I have the image analysis result, I'm going to accept that on my consumer, which is the data store. The data store will get the image analysis, which is the result, convert into a JSON object, and provide that to another consumer. This consumer is exactly that little piece of Lambda that I provided here, which I just store in the Cosmos DB. So with these 3 points of integration, I have a code that is very clean, very isolated, but very easy to understand, very easy to maintain. And even the Cosmos DB, I don't even have to care about how Cosmos DB connection is established, or manage that, or maintain that. So let's run this code locally. Oh, this is the interesting part. I can run locally, and still everything will be connected to the cloud. It doesn't have to run in the cloud to get an event from Azure Storage. And I selected some nice pictures to use as example. One is the Belgian flag. The other one is waffle. The other one is waffle and hot dog and Jeff.
Nice.
And a cat on a Roomba. Another flag, and this guy, which is always fun to play with. So let's see what happens. And maybe I get fired. So here is the terminal. Let's just move this thing to the left side, and let's upload a file. Here's my storage. I'm just refresh the connection. Yeah, okay, all good. And I'm gonna move one of these files. Let's start with the Belgian flag. This one. So once the file is there, remember that the extensions, they run with the runtime. It's the extension that establishes a connection to the service. So that's why this connection happens on my computer. It doesn't have to be in the cloud. Because the Azure extension of Azure Storage that connected to listen to events, and then once those events happen, it triggers my function, even locally. So I got here a drawing of a cartoon character, which is very accurate. Thank you, Cognitive Services. But it is red, yellow, and black. So
they got the colors.
They got the colors. All right. I think they need to improve the model for flags, like fun with flags. So the other one is, let's try hot dog. So we go with hot dog. And actually, there are some best practices we're going to talk about at the end, as soon as we wrap up here. So we got a hot dog.
This one looks better.
More information, a close-up of a hot dog on a bun.
Wow.
That's very, very accurate, except for the mustard.
Oh, that's true. It did leave out the mustard. Is it in the description? It says
no.
Dog, bun, food,
yeah, but no,
on mustard.
not mustard. Shame. Let's go with you, Jeff. Let's see what Jeff has to say.
A very attractive man standing next to Java.
From Duke, technically saying, just like, that's Duke, Jeff. That's Duke.
I just meant the word Java right there.
Oh, okay.
Let's see what it says.
It says...
Snack food.
No. A man holding a sign, posing for the camera.
Wow.
That is
I think it's
quite
Duke
accurate.
In that case.
Yeah, it means sign. Duke is holding a sign, which is you. Yeah. You are the sign. Okay. All right. So let's go with the last one here. Let's try this one. This one should be fun. Don't laugh. Not yet.
Have you run this before? Oh, look, it threw
oh my God,
right
it does
there.
not accept the kind of image. Okay, you got it. So,
hot dog.
A close-up of a hot dog. Oh, no.
Oh, there it goes. It must have reprocessed the other
Yes,
one.
yes. Justin Trudeau
Whoa.
sitting on a bench in a suit and tie. Very accurate.
That's actually pretty impressive.
It is accurate because it only got Justin Trudeau. Nobody cares about the rest, right? So it's like, that's very good. Very, very
Wow.
accurate.
Et al. It says et al.
Well, that's French. Nobody- I don't speak French. I live
Yeah,
in
don't
Canada, but I
either.
don't speak French.
I don't either.
So, okay, so this is the cognitive service demo, and it's pretty fun to play with and very easy to get started. And this source code should be on GitHub, right?
Yep. Uh-huh.
It will be. It will be. There is an old version on GitHub. We're going to update that as soon. So let's go back to the slides and just walk through the, oh yes, and most important, everything that you saw here, the extensions, the Maven plugins, the Maven archetype, Azure CLI, the runtime, the bindings, the Java library, everything that is around Azure Functions is open source on GitHub. And it actually means that you can take Azure Functions and run on-premise if you want. You can run on your own server, you can run on your own cloud, whatever cloud that is. And you can even enhance and you can implement extensions of your own. Let's say you have a custom product that needs to do some integration and you want to get some events, you can implement your own extension to trigger those events on your Azure Functions and on your whatever environment that you are running.
Perfect. So we're going to start talking now. We've shown a lot with the runtime, and we're going to focus a little bit on how some of the service stuff works for the last few minutes. So the runtime, that's the programming model. That's the component that's running your code, runs your functions. It connects to your triggers. It connects to your bindings. That's what Bruno's been running on this Mac for his local development. It does a lot of stuff for you automatically. Now, you can obviously take those functions and publish them to the Azure Functions service. This is really what makes it serverless. This is the piece that's going to take your app and run that runtime with your app across many multiple nodes in the cloud, automatically scale for you, make sure that it's highly available, highly scalable, all as part of the service. You can have the runtime without the service. The most basic example of this is when I'm developing locally. I'm just using the runtime. I'm not using the service. But I can also take one of these projects, package it up in a Docker container with the runtime, and run it in Kubernetes or run it on an IoT device. And we have customers who are like, hey, I really like the development experience, the programming model. I might not always be using Azure Functions in the cloud, but I can use that runtime wherever I need to. So a few things to note with the runtime and how it's made. It looks like we lost an E in there for nod, but that's okay. So when we talk about the runtime, this is the Azure Functions host, the thing that executes your function. And behind the curtains a bit, this is how it's made up. If we look at this diagram, we have the main host, the piece that's coordinating the triggers and coordinating the executions. That's open source, and it's written right now in .NET Core 2.1. That host may interface with different extensions, like the storage extension, the Cosmos DB extension, the HTTP extension, different extensions to let it know how to talk to and trigger from devices, and you can extend it with your own extensions. So we have people who've done WebSocket extensions that they've then published either on GitHub or in other ways for you to pull into your projects. When we need to execute a function, we communicate through an inter-process communication to a separate language worker. So on the node that your function app is running, we will spin up Java 8. We will spin up Node 8 or 10. We will spin up Python 3, whatever language we might need to run. There will be a little agent that spins up. It connects to the host through this inter-process communication layer. It's actually using gRPC and sending protobuf messages back and forth, so it's very performant. We let the Java function know, hey, you got your trigger. Here's the image that you need to analyze. Java's going to spin up your function code, do the execution, and send the data back to the host. So this host is in charge of orchestrating this. It sends all the logs back. It communicates with the service when it needs to, all for you for free. Java 8 is supported now in RC. We support production workloads. If you want to go into production on Azure Functions on Java, send us an email and we'll give you the green light and give you production-grade support. It will be generally available very soon, and we have Java 11 planned for sometime next year. If we look at the service components, there's a few pieces. There's different instances of your function. So when Bruno runs his function locally, it's running on a single instance, his machine. And that single machine is pulling in those images. But when we're running in the cloud, we can scale you out across hundreds of instances so that your application can scale to whatever traffic needs are there. But that also means that you might have multiple copies of your app running in parallel at the same time. You don't have to worry about it, but it can happen. We have an HTTPS front end that we manage for you. So if you want an HTTP trigger, we give you some certificates out of the box. We'll take that traffic, send it back to your app, so you don't have to worry about managing an HTTPS front end. And we give you customization as well. So if you want a custom domain name or custom certificates, you can always set that up. Now finally, probably the most powerful part of the service is what's called the scale controller. And this is the brains in the cloud that is trying to determine for your app, do we need to scale this out? Or should we scale it in? When do we need to deploy new instances? How do I manage the instances? Are they all healthy? I'll show you in a little bit of how that works. In fact, right now, let's show a quick scale demo. Now, for the sake of time, I'm going to abbreviate the sum. But that's fine. We're going to come here to, where is Firefox? Right there. Thank you. I have a simple Azure function, which is deployed that I can connect to Twitter. So to give you an example, there's another service here in Azure called Azure Logic Apps. This is also serverless in the sense that I don't have to manage any servers. This will scale to whatever I need it to. But this is nice for pairing with my functions because it gives me a bunch of additional integrations. So I can create these logical workflows and connect my functions to different services like DB2 on premises, like Twitter, like GitHub, like whatever other service I might need to, Salesforce. It's taking some time to load. I might not even wait for it. Anyway, I've connected my Azure function to trigger from new tweets coming in on Twitter. Now, I'm going to watch what happens when those tweets come in. And hopefully this works for us. It seems that the internet is taking its time. We're getting some stuff that loads. So I'm going to open up what's called this live metric stream. This is some monitoring you get for your Azure functions. And I can actually go into this live view and see real time what's happening with my application. So it's spun up here. And the important things I want you to know, I'm going to push a bunch of load at this in just a second. I have no incoming requests right now, okay? There's no one who's tweeting whatever hashtag I'm going to have this listening to right now, okay? The other thing to pay attention to is how many servers are in line. Now, this is serverless. I don't have to worry about the servers, but we need servers behind the scenes to run your code because we haven't solved that problem yet. Right now, there's only one server online, and it's running 0 requests a second, okay? For whatever reason, that one's still hanging around. Now, I'm going to push enter here on my machine. I'm actually doing this remotely because the Wi-Fi here struggled when I tried to push a bunch of HTTP requests at it. And I'm sending some load towards this Azure function. So you can see here it's spiked up right away. It's starting to process some requests. There's a little bit of latency here, but you'll notice here in just a second, as these requests continue to build, that automatically our scale controller is going to start provisioning more servers for you. So my machine's taking some time to get the requests up. Right now my CPU is getting pretty close here. So we should see here in just a second or two, hopefully. I saw some latency before. Right there we spun up, so now there's 2 servers online. If I keep talking, pretty soon this will go to 3, 4, or 5. Where our scale controller is saying, hey, we need more horsepower to distribute the load, and it's going to very quickly scale out for us. It seems to be jumping around a bit. It's fine for now, but hopefully that gives you some insight into what's happening here. It's just scaled out to 3 servers and so forth. Last night when I ran this, we're at 4. I got to about 10, 12 servers at steady state. So what's great here, I don't know how long it takes one of you to deploy a new server and get your app deployed to it. But just in the time of me talking here, I now have 4 fully powered servers in the cloud running my simple Azure function processing these requests. And it will continue to scale up as well as I go. And I'm also getting some nice exceptions now. So that's my cue to switch. OK, so with that, let's come back over here to the PowerPoint. Because I want to show you now what you just saw, okay? So I had my Azure function, which may not be running on any infrastructure. My event source in this case was an HTTP trigger. And I have the scale controller, which is looking and trying to decide what things need. Now, when that first request comes in, the scale controller may need to instantiate a brand new app. It might need to put my app on a new server. If I haven't called this thing in about an hour, it's very possible we don't have your app running on any servers. So the scale controller says, hey, hurry up and get Jeff's code onto this server. Now, just a quick drill down into what happens here. we have to take a server. We've got to start the host process on it. It's going to receive all your environment variables, your connection strings, and load that onto the server. We're going to start the Java process. We're going to read in your function metadata to see what triggers and bindings you're interested in. That Java process is going to start up and connect to the host. The host is going to receive whatever that trigger event was. Then we're going to pass that to the Java worker to execute, and then the host executes. So there's a bunch of stuff here that has to happen. This is where Bruno mentioned sometimes there's a little bit of latency in that very first request where we first create a server if there's not one already there. And that's because we have to do a few steps. I will say, though, we're actually optimizing a lot of this. So we don't actually start from scratch every time. We actually have a pool of machines that already have the host running on it. They already have a bunch of these components started up in advance. So we just simply have to stick your code in it and start running. We don't have to kind of boot it up from scratch. This is like the worst case scenario, but we do a bunch of optimizations to make this better, and we're continuing to make more optimizations to make that improved. Now, as the load continues to increase, we might scale out to multiple instances. You saw in my case, I got up to like 4 or 5. Sometimes it will scale even faster, depending on how much load I can push to it. And the scale controller is going to manage all that scale for you. If a number of time has passed when those events stop, like if I shut off my load test right now and I wait for 30 minutes, the scale controller is going to start scaling me down again. Now, I'm not charged for how much it scales me out. I'm only charged for when I'm actually running code, so I don't have to worry about how much I've scaled out or in or how much servers are sticking around. I only pay when my code's actually executing. So we already talked a bit about cold start. It's that initial time to start up an instance when there isn't one already there. The only thing here I'll mention, there are a few things that you can do to help with cold start. Keep your dependencies small. If you have an app and you've pulled in 30 different dependencies and you have 20 different functions in the same app, that's all additional files, that's all additional methods we have to start up on that cold start. So the smaller you can keep your deployment package, the faster you'll start it up. There is this kind of hack where you could just create a pinger. If you just poke your function every 5 or 10 minutes, it will stay warm because you're poking it. So that is an option. It's one that we hope you don't have to use, but it's worth calling out.
Can you use a function to ping another function?
You can actually use a function in your app to ping itself, and it will keep itself alive.
There's a scheduler on Azure Functions,
Yes.
which you can basically build a function that runs every 5-10 minutes, exactly that, and then pings a REST API.
Self-pinger. Wake myself up. Wake myself
exactly.
up. And you can also choose to host your functions in a non-consumption plan. So you can, instead of saying, hey, I want this dynamic compute, you can say, I'm actually just going to pay you for one server 24/7, and then you can auto-scale from there. And in that case, you'll never have cold start because you're paying for a server constantly. Okay, so in the last few minutes here, we're going to hit some best practices very quickly. We've already mentioned a few of these.
Yeah, especially for Java development on Azure Functions, the JVM is provisioned once, and then your code will be executed as many times as possible, as many times are needed. But the one thing that for now the architecture is we're gonna make sure that there's no state, there's no current threading or anything like that. So we're gonna create a new object of the class that has the method that you tagged as a function. So if you do want to take advantage of sharing objects or sharing connections or sharing instances of things that take some time to be created or provisioned or constructed, then you have to go back to the old-fashioned method of using singletons and keeping instances in static fields on your class. Limit and reduce dependencies within app. So as we said at the beginning, a function app is your deployment unit. Within a function app, you can have multiple functions. If you have one single Maven project that has dozens of functions, but you can easily see that this function has nothing to do with that function and they all bring their own dependencies, maybe you should break that down into 2 function apps so they can scale faster and independently. Use the right trigger for the right job. If you can, you should take advantage of the triggers and you should take advantage of the bindings. I would say HTTP is a great way to get things started, but in reality, you don't want to use HTTP. You want to use Kafka events, storage events, blob events, etc., because those are the real data scenarios for event-driven system, highly scalable serverless environment. And do not neglect the outer loop. Everything that you can do to make sure that you know what's going on with your serverless functions, do. And automate everything. You can automate the deployment, the CI/CD, on Azure DevOps or using Jenkins. You can automate the deployment of your the compilation and then deployment of your Azure Functions using Maven, and of course using the plugins available for Jenkins or Azure DevOps. And monitoring, as Jeff showed, there's a lot of monitoring that is already provided by default, but I would say you could also add monitoring SDKs within your app to provide more fine-grained data that is more business-related, perhaps, for your function.
Awesome. So thank you all so much. Here's a link to try it. If you have questions, we're out of time, so we'll probably just pop out right over here, or if you come down while they set up, then we'll answer some questions. Please fill out your evals. Hopefully this was useful. Give us some feedback. Let us know if you love this, what worked for you.
And 5 stars.
And 5 stars, because we tried to be good stars for you with some nice images. So thanks everyone so much. Go ahead and give Azure Functions a shot, and let us know if you have any questions.
Thank you. Bye.